Good morning, all. In the last class, we clearly discussed what is root locus, okay, and why we need root locus, and what are the basic rules. So, in the today, we are going to apply this concept and solve one complete problem step by step. But here, I'm not just solving. I will explain why we are going to do each step. Okay. So here we are giving g of s equal to k by s plus 1 into s plus 2 into s plus 3. So whenever you see this type of problem, first don't trust to draw plot. Always analyze the system first. That means, so what is the, so analyze the poles and zeros. Okay. Now what is the pole and what is zero? So poles are always, which makes denominator is 0. Okay. Zeros are always, which makes numerator is 0. Okay. Poles are values of s, which makes denominator is 0. This is numerator makes 0. So now check carefully. What is the numerator? Numerator is only k we are having. So s term, so no s term. That means no zeros. That will be m equal to zeros. Now check the denominator. Denominator is s plus 1, s plus 2, s plus 3. That means if equal to each to 0, that means s plus 1 equal to 0, that will get s equal to minus 1, s equal to minus 2, and s equal to minus 3. So this is minus 2. Then minus 3. So these are like poles P1, P2, P3. So zeros are z equal to 0. So number of poles are 3, number of zeros are 0. So these poles are the starting point of our root locus. Okay. Now let's draw graph. That means now let's draw the graph here. Let's just go through this graph once, check this figure. Okay, this graph. So here horizontal is real axis. This is a plus and this is a minus. Okay, here the vertical is imaginary axis. Okay, this is the plus, this is the minus. Okay, so now mark the poles using these values, minus 1, minus 2, and minus 3. So check here red box, right? This is the minus 1, this is minus 2, this is the minus 3. On the real axis, we mention all 3 poles. Okay, now observe carefully. All poles are in left half of the plane. So sorry, left half of the plane. That means already system looks stable, right? But as k changes, behavior will change. That's what root locus shows. Okay, as k changes, behavior will change. That is the what root locus we're going to discuss here. Okay, now let's go to the rule number 1. Okay, what is the rule number 1? Number of root locus branches equal to number of poles. So here we have only 3 poles. That means definitely we'll get 3 branches. Okay. Okay. From each pole, one path will start. That's what branches, right? So from each pole, one path will be start. One path will start. Okay. That is the rule number 1. Now let's see the most. This is most important but most confusing also, but I'll explain a little bit clearly. So root locus exists only on the real axis, where number of poles plus zeros at right will be odd. That's what we discussed rule number 2, right? Root locus exists on real axis where number of poles plus zeros to the right is odd. Okay, when you count right, this should be odd. Okay. Why this rule we mentioned? Because root locus follows angle conditions, and this rule is simplified of the Zo's version. Okay, now check interval by interval. Okay, how many poles are just say I mentioned here -1, -2, -3, right? Okay, how many poles on the right side in between 0 to -1? Check here, it's very, very important. How many poles are there in between -1 to 0? If you just see this, check this graph here. Here I wrote -1. Okay, then right, there is no zeros and poles. This is -1, start with the pole right now. Okay, nothing is there. If you just keep your finger here, maybe keep your hand here, then check right side how many poles or zeros are there. Okay, because it is even, because nothing is there, because this is even, because so no locus will come in this picture. -1 to 0, no locus will come. Now check in between -1 and -2. In between this -2 and -1. Okay, so how many poles? Just check from this -2, how many poles are there and how many poles and zeros are there from here to this side, right side, always check right side. So there is one -1, right? There is one pole is there, that is the -1. That means we have a odd number will be there. That means definitely locus will be exist. That means locus will exist. Okay, then check one more point between -2 to -3. Okay, poles to right. Check poles to right from -3. How many are there? How many are there? There are two, -2 and -1, right? There are two poles. That means this is a even number. So that means no locus. Definitely no locus will be. Then one more point, -3 to and minus infinity. Take -3 to minus infinity. From minus infinity, how many are there? Because -3, -2, -1. There are like three, right? -1, -2, minus how many are there from infinity? This -3, -2, -1. That means poles to right will be 3. 3 is a odd number. Definitely locus will exist. So what are the points locus will exist? Locus will exist only. It will be more confusing, right? Wait. So locus will exist only the in between -1 comma -2. The -1 comma -2. This is what, right? In between these two, -2, -2, -1 comma -2, and -3 to minus infinity. Because when you start from -2, then only there is a one pole, so definitely the locus will exist. And then here -3 to minus infinity, there are like when you count from here, then we can say this. So in this area locus will exist, and this area locus will exist. This is what -1 comma -2. This area, this is the area locus will exist, and then -3 to minus, this is the area locus will exist. These 2 points. Take it, okay? These 2 points only locus will exist. Okay. So we have now we find out where exactly locus exists. Okay. Now let's go for the rule number 3. So now we have 3 poles but 0 G's. So where will roots go finally? Because they cannot stop, right? Because of no zeros. So they go to infinite. So this path is called asymptotes. This path is called asymptotes. So here number of asymptotes means n minus m. So poles minus 0, that means n minus m equal to 3 minus 0. That will be 3. Okay. So we need to find angle of asymptotes, because how to draw the angle from the point. So angle of asymptotes will be the formula. What is the formula? Angle of asymptotes theta equal to pi into 2k plus 1 by n minus m. So because we have number of asymptotes are 3, so definitely we should know about 3 values. Start from k value 0, 1, 2, 3. We should take only 3 values because of number of asymptotes 3. It should equal to number of k values. So when substitute k equal to 0, 1, 2, then we'll get the 3 angles. When k equal to 0, we'll get 60, because when k equal to 0, right, then become 0. This is called 1 by 1 by 3, is pi. So pi by 3 is equal to 60. And k equal to 1, 3 pi by 3, then you will get 180 degrees. And k equal to 2, 3 pi by 3 is equal to, I think we will get 270 degrees. 60, 180 and 270. And k equal to 2. And this is 5, yeah. 5 pi by 3. Okay. So that means root will move in these directions only. So roots will move only on these directions. That means 60, 180 and 270. Now we need to find, center of gravity. That means from where asymptotes will start. We got 3, but where exactly to start? These angles, these asymptotes will start. That spot is called center of gravity. That's called center of gravity. Decides where root locus start. Okay, what is the formula? What is the formula? Sum of poles minus sum of zeros by n minus m. The what are sum of poles? -1, -2, -3, minus sum of zeros will be zeros only by this is n minus m. Okay, if you will solve this one, what we'll get? We will get -2. So centroid is -2. So then what we can assume? All asymptotes meet here. Okay, all asymptotes meet here. So that means -2 only the root locus starts. So put protector and draw. At -2, we have 3 angles, 60, 180, 270. From here, anyway, this is 180 on the axis only. And then from -2, you can draw the protector and draw at 60 degrees and 270 degrees. Okay, so all 3 angles we draw. Okay, so now we know the where exactly starts, root locus starts, and then we have the angles. Okay, 60, 180 and 270. Okay, so now we need to find out breakaway point. That means between -1 comma -2 locus exists. Because of only -2 we found out definitely between -1 -2 only locus exists. So roots will move towards each other. So at some point they meet and leave real axis, right? That point is called breakaway point. So they meet, leave and right. That means that point is breakaway point. They meet and leave the real axis. So now what is the formula for that one? We have breakaway formula is sum of 1 minus poles equal to sum of 1 minus zeros. Because zeros are not the 0. Sum of poles, that means 1 by s plus 1, 1 by s plus 2, 1 by s plus equal to 0. So now from this question you got, finally we'll get s values are 2, minus 1.42, minus 2.57. So now which one exists on -1 comma -2 in this range? -1 comma -2 ranges, or -3 -2 ranges. So only 2.57 is not considered, right? Only we should consider the -1.2 because we found out. So definitely will be there on this region only, -2 to -1 range. So now we got -1.42. Now just keep it a main range of -2 to -1. Just keep it here -1.42. This is only valid. That means this is the means when you find this -1.2, this is the starting point of your root locus. This is what exactly will start. That means center of gravity will give rough idea to draw the asymptote lines. That's what we draw it from -0.2, sorry, -2. So, but breakaway point, exact point where root locus should be start. Okay, that's what we can say -1.4. Okay, this is very, very important point. That's different between center of gravity and breakaway point. So now we found a breakaway point. Okay, what is the meaning of breakaway point? Means two roots are meeting at this point. Okay, that means -1.42. Okay, that means That means one root from -1 and one root from -2. That's what I showcased in the -1 and -2. Okay, so now they meet at -1.42. So now now the question is, after meeting what happens? After meeting what happens? Okay, because they cannot continue on the real axis, right? They cannot continue on the real axis. Okay, because beyond this no valid locus. So they live on real axis. Okay, and move into complex plane. So now where they will go on the complex plane. Okay, so now we don't know exact path, and this way or this way or this way, this way, we don't know exact path from there. So we only know our starting point, that is 1.42 minus 1.42. Okay, this is the point, we know the starting point. So definitely we know the direction is a complex plane. Okay, but we need one more fixed point. So we need one more fixed point. Okay, so now what we'll do, we'll check whether system has imaginary roots. So we need to check system having the imaginary roots. So for that we should write 1 plus g of s is equal to 0. So from this we get characteristic equation. So for that one we apply the Routh test. Okay, so that's what we discussed in the previous lecture also regarding the Routh test. So Routh test is very important to find the imaginary roots. Okay, so now we have the characteristic equation, then we know what is the g value from your derivation, right? So then we can substitute all the values here, just make equal to 0. Okay, so then just solve this equation. Now we look at this is a characteristic equation we are getting based on our block diagram. So these are the things they provided. This is the only thing they provided. Substitute here equal to 0, then we'll get. Then after that make it a Routh array table. So even numbers and odd numbers, and then we'll find out C1, B1, B2, and C1, C2. Then make it as equal to 0. Then we'll get k equal to 60. So this is critically stable. Okay. Now we need to find the roots. How to find the roots? We know very well by using this formula. C s square plus d equal to 0. So to find the c values, this is a c value and this is a d value. That means n minus 1th. Okay, n minus 1th row. So then we know c value, we know the d value, then substitute here. Then finally we'll get the roots are s equal to plus or minus 3.32j. Okay. So the root locus will definitely pass these points. Okay. So now we have a breakaway point and we have a imaginary axis point. Now we have a imaginary axis point and we also have breakaway point. So now we can connect them. Okay. So now we can connect them. So see. So this is your breakaway point minus 1.32. Okay, now connect these 2 points, so we can possibly pass through. So from 1.32 you can make one line to 3.32. So path can be many possibilities. So we need one more confirmation point. Where should actually go this point? Okay. So now we assume one more point, that is. So there is small mistake, just now I corrected. So this is minus 1.4, not this point. Okay, this is minus 1, this is minus 2. In between there is a point minus 1.4, that is called breakaway point. This is a point we found out, right? And that is minus 1.42. So from this minus 1.42 we need to draw like this till where is the imaginary axis? So till this 3.3. Here also minus 3.3. Okay, now we know the starting point, now we know the ending points also on the imaginary axis. Okay, here and here. But the only thing we don't know, in between, where is the other point. So in between these 2 points, so path can be many possibilities, right? So we need to find one more confirmation. But roughly we can draw from this point to like this and from this point to like this. But what exactly the one more confirmation will get some proper way. So for that purpose, we need to find the trial point. Okay. From the trial point, we can get exactly one more point to draw your final diagram. Okay. So for the purpose, we have to find out the trial point. We assume like that is SC. Okay. So so from here, suppose if you resume here, this is a point. Okay. So if you assume this point here, then come suppose then what happened? This thing on this side. So this side will be -1 and this side will be -1.5. So that is -1 plus or minus 1.5j. Just assume like that. That's trial point. Okay. But now we need to check whether this point lies on root locus or not. Okay. So for the purpose, we are using the angle criteria. Okay. Now what is the angle criteria? Angle of zeros minus angle of poles equal to 2i plus 1 into pi. So here zeros are 0 and only poles are there. Okay, zeros are 0, only poles are there. So condition becomes sum of angle from poles equal to odd multiply into pi. So from this trial point, we can join the lines to all poles. That is -1, -2, -3, right? So from this one we can join. So from this trial point, right, we can join to -3 all poles, -2 and minus. This is a blue line. What I'm just showing here, a blue line. From this one there is some angle. This one there is some angle. So this one some angle. So we need to measure these angles. Okay, by using trial methods. Okay, this is one alpha, this is theta 1, this is, or maybe you can keep theta 1, theta 2, theta 3 also. But up to us. If you want to keep alpha, or maybe theta 1, theta 2, theta 3 also, you can keep it whatever. So after that, add them. That means alpha plus theta 1 plus theta 2 equal to, okay, odd of pi. Okay, suppose if you just assume each and every values here, suppose if you got I equal 0, 1 and 2, so then if the results definitely near to pi only, because if near to pi only, because the pi will be there. Suppose 0 means this became a 1, that's pi, or maybe 1 pi, 2 pi, 3 pi, or pi. Okay, 1 pi or 2 pi or 3 pi. Okay, there's a definitely points less on the root log because near to 180 degrees. Okay, so but definitely points less on the root axis, otherwise it will reject it. Okay, so now we identify, okay, this is the best point. So based on that one, then you can draw the complete final root locus diagram. Okay, this is the starting point and this is the ending point. In between part also we found out. Okay, definitely this diagram comes on at 180 degrees only, right? This 180 degrees on top and bottom because of this the trial point. Okay, so from that we have find out what are the poles. The first point, what are the poles, then breakaway point, then imaginary axis point, then we find out asymptotes, then we find trial point. Okay, trial point. Okay, so once we know, so then we understand the curve is very smooth and then symmetric about real axis and no sudden turns. So upper and lower curves are my exactly on the mirror images. Okay, so breakaway point gives starting point of the curve, and imaginary roots gives conformed point. Okay, asymptotes give final direction. Angle criteria confirms the valid path. Okay, the valid path confirmed by the angle criteria. So then combined all, we get exact root locus diagram. Okay, so this is the completes the root locus construction. and next one more we'll discuss one more problem. We'll get more understanding. Okay. So now let us take another problem. This problem is slightly different from the previous one. Okay, because in the previous problem we had only poles. Okay, but this problem we have both poles and zeros. Okay, this is what the problem given: Kc into 0.5 s plus 1 by s into s plus 1 into s plus 0.5. So here numerator gives zeros. Okay, denominator gives poles. Okay, so now first identify the poles. What are the poles? How to find? Make it everything to 0. This 0, this 0. Okay, then become s equal to 0. That's called p1 equal to 0. Then p2 equal to minus 1. p3 equal to minus 0.5. And zeros, how to get 0? 0 will get 0.5s plus 1 equal to 0. This point. Okay, so then you will get s equal to minus 2. That means represent zeros is equal z1 equal to minus 2. So we got number of poles will be the n equal to 3. Number of zeros m equal to 1, because we have 3 poles and we have 1 0. Okay, now we need to find out number of asymptotes. That's called n minus m. So we have a 3 minus 1 equal to 2. So there are 2 asymptotes. Okay, now we need to find out angle of asymptotes. Okay, angle of, because here we got 2, right? We should take only till 0 comma 1. We cannot take 3 and 4. Only k equal to 0 comma 1. So what is the formula? So formula will be pi into 2k plus 1 by n minus m. So now we need to find only for these two values of k. When k equal to 0, we got substitute k equal to 0, we'll get pi by 2, that is called 90 degrees. Okay, then substitute k equal to 1 here, then we'll get 270. So here what can I identify? So these here asymptotes are vertical lines. Okay, the asymptotes will be the vertical lines like this. This is 90, this is 270, right? Definitely somewhere will come like this, 90 and 270. Okay, so now we need to find out centroid, center of gravity. That means sum of poles plus sum of 0 by n minus m. So we have the poles and we have zeros. Okay, now substitute here, then you will get the final value 0.25. Okay, now we know the centroid is 0.25. So note this clearly, because centroid is right side now, because this is plus. Okay, the centroid come on this side, not on this side. Okay, so this is very, very important. Okay, now plot poles and zeros. Now before going to break apart, first we need to plot poles and zeros. Now we draw the complete plane. That means what are the poles and what are zeros. Just so what are this one? Minus 0.5. So make this, and then minus 1, and we have zeros are minus 2. That's why we use this symbol for minus 2. Okay, so now keep this one 0, this is 1, sorry, so this is poles, 0, 1 pole, and 0.1 and minus 1. So here 0 is only the minus 2. Okay, now we have 4. Okay, so now what is the concept? Okay, so when we check the intervals, so between 0 to minus 0.5, so that means in these ranges 0 to minus 0.5. See the right side, how many things are there? 0 to 0.5. So we have, when we keep it here right side at 0.5, then we understand how many things are there. Only definitely there one pole exists. So that means there one definitely in this range locus will exist because of the odd number. So if we just assume 0.5 to n minus 1, so in this range 0.5 to minus 1, when I keep it finger here, then check right side, the count will be 2 members. That is, one is 0.5 and 0. There are 2. Definitely this is even. So even means no locus, right? And between minus 1 comma minus 2, in this range check, -1, -2 ranges, count will be 3. So definitely odd. So there is a possibility of locus exist on this range. So then beyond -2, no locus because count will be 4. Beyond this -2, definitely no locus. So here what you find out? Here you find out locus exists only in this range 0 to -0.5 and -1, -1 to -2. Okay. So now we know definitely by using the breakaway point we can find exactly where exactly starts. Okay, either it between 0 to minus point or maybe the where the exact root will meet. Okay, so now using the breakaway point we'll just find out. Now write sum of the poles is equal to sum of zeros. So this is the formula 1 by s plus 1, 1 by s plus 1 by s plus 1 by s plus 1 plus 1 by s plus 0.5 equal to 1 by s plus 2. Okay, that means sum of 1 by s minus poles equal to 1 by sum of 1 by s minus zeros. So when you solve this one, we'll get s equal to minus 0.22. This is called breakaway point. Okay, that means definitely it will exist. Okay, so now it will exist definitely on the range of 0 to minus point because of we got 0.22. That means definitely in here that will come. Breakaway point will be 0.22. Okay, roots from 0 and root from minus 0.5. So move forward each other. So then meet at 0.22 and leaves on the real axis. So now into the complex plane, just check here each and every point will not. So now we need to fix one fixed point. So use the Routh test. The same thing we done previous also. Now use the Routh test. So now write the our characteristic equation. That is 1 plus g equal to 0. So we know these all equations. Just make it combine together, multiply together. Then we'll get g. Then 1 plus g equal to 0. So now from this polynomial equation, apply the Routh test. Okay. Now apply the Routh test. So just write odd numbers and even numbers. Then write b1, c1, all these things. Then find out exactly what values of Kc we can find become just unstable. So then we can say definitely depending on the Kc value we can say what type of value it is. I think now here we get Kc equal to 3 will get. Okay, and then simply we can say system become unstable if Kc is equal to 3. So now can you find out imaginary roots? How to find out imaginary roots? A square plus d equal to 0. Now substitute this c value and d value. Okay, this is 3 and this is d. Now equal to 0, then we'll get imaginary axis. That is s is equal to 1.4 into j. So definitely this is the imaginary axis crossing point. Okay, now combine everything. This is a point where, right? So when so here one branch start at -1. Okay, goes directly to 0 at -2. Okay, so now starts at 0 to 0.5. So meet at 0.22. Okay, now we're going to complex plane. Now pass its near 1.414 and then there is a minus 1.414. Okay, so and then follow the asymptotes. So definitely asymptotes are vertical because this is at center of gravity we got 0.25, right? Just keep it 2.25. Now at center of gravity rather this asymptotes, this one is 90, one is 270. It's passing through 0.25. Yes, okay. So here asymptotes are lies in the right of plane. So root locus go to right side also. So therefore system become unstable for Kc values are when there is a high Kc values. The system becomes unstable for higher K values because it's going to the right of the plane. Okay. So here the root locus gives complete picture. So we can say when roots start, how they are moving and where they are going. So when system become unstable, each and every point we can get by using the root locus. That's why it's very, very important. Okay. So we solved root locus problem with poles and zeros. Okay. Now we got more understanding compared to the previous problem. Okay. Thank you.